So you've joined the performance testing crash course, and my name's Dustin Whittle. So we're going to talk a little bit about capacity planning and load testing on the server side, and client-side optimizations, and really understanding how performance affects end user experience and application performance. So again, my name's Dustin Whittle. You can find out more about me at dustinwhittle.com or follow me on Twitter at Dustin Whittle. I'm from San Francisco. I've worked on a variety of projects in the past. Currently, I'm a developer evangelist for an application performance company called AppDynamics. Previous to that, I worked for a company called Sensio Labs doing consulting and training in the performance space. And then previous to that, I brought a PHP framework to Yahoo called Symfony and built out properties like Delicious and Yahoo Answers. So I've worked on some high-performance properties and scaled out some large applications in the past. And that's really where a lot of this talk experience comes from. But really, why does performance matter? So I know I'm talking to a room full of engineers, but sometimes it's good to understand the business impact. So some of the stats that I've found are, Microsoft found that Bing searches that were 2 seconds slower resulted in a 4.3% drop in revenue per user. And when Mozilla shaved 2.2 seconds off their landing page, Firefox downloads increased 15.4%. So you got 30 million more downloads just because the page was slightly faster. And making Barack Obama's website 60% faster increased donation conversions by 14%. So he raised a lot more money just because the page was a little bit faster and people were able to donate a little bit easier. But the best statistic that I've come across, and this really comes from the Velocity conference, is that Amazon and Walmart increase revenue 1% for every 100 milliseconds that they shave off the end user experience time. So the reality is that the performance actually definitely impacts a business. I think every major web company, especially all the reputable ones, really treat performance as a feature and not as an afterthought. And I think it shows because they all invest heavily in performance engineering. And it's not just about making sure your site is fast, it also needs to be available. And I think they all realize that performance directly impacts the business's bottom line. But how fast is fast enough? That's the real question. So I think 50% of people will abandon a page after about 3 seconds, and Google aims to keep pages under 100 milliseconds, which is pretty fast, especially when you have complex interactions behind there. But how does your brain perceive page load time? So 100 milliseconds feels instantaneous. It feels like you're flipping a page in a book. After a second, you can still think seamlessly, but after 3 seconds, you start to lose attention, and after 10 seconds, you pretty much always abandon. And I think everyone's probably experienced this at some point. If you've ever been in an online checkout where you click the checkout button and it just waits, and you're not sure whether it's working or not, do you click again? Do you wait it out? And you quickly lose faith in that brand and in that experience. And I think the most spectacular failure in the last decade has probably been healthcare.gov. And I only say that because the only time I've ever seen a president go on live TV and apologize for a slow, broken website. So again, it's not just about making sure the website's fast. It also has to be available and have enough capacity for the demand. So I'm going to go through a bunch of different examples of tools that I found. If you need an app to test, it's really easy to launch a Spring app with Spring Boot and Cloud Foundry by Pivotal. So again, you can just follow along and feel free to just follow the examples. So the app that I'm going to test is just the Cloud Foundry sample app called Hello Spring Cloud. So github.com/Cloud Foundry samples. And you can very easily clone it right here. So feel free to follow along or download the slides later and go through this. It's as easy as Maven package, and then sign up for a Pivotal Web Services account, and you can simply call CF push and deploy the application live. So this application is running at spring1-demo.cfapps.io, and this is what I'll use to load test. I'll bounce between this and my personal website. And basically, it's a hello world in Spring. It's relatively simple. So all this is doing is printing out a bunch of environment data. So again, tools of the trade for performance testing. The first thing I like to talk about is really you need to understand your baseline performance. So you need to understand how much overhead is the application server adding, how much overhead is my framework adding, and then for hello world versus a complex interaction. So I like to understand what's the most that I can get out of this hardware. Through maybe Nginx directly or through Tomcat directly, and then how much can I get through my actual application stack. So I usually baseline a static page like HTML asset, a hello world in my framework, and then my actual application. just to give you an understanding of how much performance you can get out of each piece of the stack, and how much the relative overhead is for each piece. Like how much overhead does Spring add to that? How much overhead are different application servers? So a great tool that I commonly use is Apache Bench. If you've ever installed Apache, you have access to Apache Bench. It's relatively easy to install. So apt-get install apache2 utils, and then you can run this command. So what this will do is essentially you're calling Apache Bench with a level of 1 concurrent user for 10 seconds, and I just want to load test 1 concurrent request for 10 seconds and get the throughput and the average latency for this website. So I'm going to go through these examples live, and hopefully the switching back and forth doesn't drive you crazy. I built this talk to be a little under an hour and a half, so if you have questions along the way, please don't hesitate to just raise your hand. So this is a relatively simple example. Can everyone read this? Yeah? We'll find out. So here, what I'm doing is I'm just going to load test Apache Bench with -c concurrency of 10, with -t, which is the amount of time, 10 seconds, and -k, which is benchmark mode. So no delay between each request. I want to send them as fast as possible. And then what you'll get is a simple output. And what this will tell you is that I was able to get 353 requests in 10 seconds, and I was averaging 35 requests a second with a mean time of 28 milliseconds per request. So you can run this against Hello World just to figure out what Apache, Nginx, whatever application server you prefer can get through just a Hello World, and then you can run this on your actual application. But the reality is that applications have different performance characteristics. Like your homepage might be highly cached, whereas you might have a checkout process that talks to a bunch of third-party APIs. So you need to understand the performance of each different transaction. So we'll walk through a couple of different scenarios. So again, the output looks like this, pretty straightforward, and then you can increase concurrency over time. So this is the command that I just ran, and this is the output. Apache Bench is all right, but I much prefer a utility called Siege. I think Siege is a bit more flexible. So again, you can just apt-get install Siege. It's relatively easy to use, and it follows a similar convention. So I can call Siege with -c concurrency of 10, with -b, which means benchmark mode. So there, again, there's no delay between requests, send them as fast as possible. And then -t is how long do I want to send requests for. So in this case, 10 seconds. Now, these are just examples. You don't really want to just load test for 10 seconds because that doesn't really tell you much, but it gives you a baseline for performance. So this command again looks like this. And what you can see is something very similar. So the output should be roughly the same. So we have about 36 transactions a second with a mean time of, where is it? About 0.26 milliseconds, or 0.26 seconds, 260 milliseconds. And then you can see the longest transaction, shortest transaction. So this gives you a basic idea of requests per second and basically throughput for the application. But oftentimes, just load testing a single endpoint isn't really useful. You want to load test through scenarios. So you want to build out a way to test all the endpoints in your application. But oftentimes, it's how do you figure out every endpoint in your application. So I found a nifty trick to actually do that. So you can crawl the entire application with a tool called wget, pipe that through a proxy, and then sort all the unique URLs. And what this will give you is it'll crawl your application as if it were a search engine, discover all the URLs, and then allow you to have a unique list of those so that you can benchmark against that. So sometimes frameworks provide nice utilities so you can just dump all the routes and then it's really easy to figure out, but oftentimes you miss a lot of the production endpoints. So let's take an example. So this relies on sproxy. So this is written by the guy who writes Siege. Essentially all this is a transparent HTTP proxy that will dump the URLs into a urls.txt file. So let's go through this.
Sorry, what was it?
Yeah, it's sproxy and Siege. And my laptop has decided to freeze, so we're just gonna play it like this is working as expected. Uh-oh. That's not good at all. Okay, stand by while we have some technical difficulties. I think I might have to do the old turn it off and on. Oh no. My apologies, folks. This worked an hour ago, if that counts for anything. So, any questions so far? Is there an ant wrapper for sproxy? I don't think so, but I don't know, to be honest. Any other questions?
What was the comparison between Apache Bench and Siege?
Siege is just more flexible. There's more configuration options, which is why I prefer it. Also, the output's just a little cleaner. Any other questions so far? Yeah, so in that case, I would use something as simple as just running Siege. Because if the whole idea behind the sproxy, which we'll hopefully figure out right now, is essentially what you can do is just crawl your application as though it were a search engine, and then you could very quickly figure out all the unique endpoints in your application. All right, let's try this again, this time a little more smooth. So we have sproxy-o with urls.text. So all this is going to do is run sproxy on port 9001. And then from here, I can simply run wget as a spider. So there's a couple of things that I use wget for. In this case, all we're going to do is run wget in recursive mode for 1 level deep. So just give me 1 level deep, just to keep it simple for this example. In spider mode, and pass all the URLs through the HTTP proxy. And then that'll dump them through sproxy to this urls.txt file. And then I can just grab a unique list of URLs from there. So I have a more complex application on acmedemoapp.com. I know, very original. So we're just going to run and index that application. So that application is just a really simple e-commerce site that looks like this. So it's just a really simple e-commerce site. So basically the URLs that we should get is a unique list for that particular application. So all it's doing now is it's going to crawl the application, dump all the URLs to the text file, and then I'll have a unique list of URLs for that endpoint. Now this greatly depends on the bandwidth available to this laptop when you're running load tests, because all the requests are coming off of this laptop, which is probably a bad idea. So hopefully this all works nice and smooth. And what this will give you is a urls.txt file that looks roughly like this. So here I have the home page, about page, a view cart page. You have the ability to switch between currencies. I can log in, I can register for a new account, and then I can go to a variety of landing pages for each category. So I have a category for books, mugs, stickers, and then we have terms of service static content page. So when you have an application, again, each one of these transactions has different performance characteristics. So you really want to get an understanding of how each one of these performs. So when you're doing capacity planning, you know how many servers you need. Because when the world shows up to your website, they don't just go to the homepage. The homepage is usually highly cacheable. They actually have to go through whatever the functionality of your application is, and that's usually where you have the performance problems. So once we have this list of URLs, we can benchmark traffic across all the unique URLs using Siege relatively easily. So let's do that again. No. My apologies, folks. Any more questions so far? Because this is not going what I would call smooth. Yeah, absolutely. So one of the things that Siege makes it really easy to do is to pass in HTTP state. So if I want to create a cookie jar, and so that's actually the next example, is when you want to maintain state across the application. Like the first thing I want to do is log in, post this username and password to some form, take that cookie data, keep the cookie data, go through some other request flows. That's a really common pattern. So I use a different tool for that, but Siege is definitely capable of keeping that state. So you could just pass in a cookie jar and it'll pass those cookies right along. All right, so let's just do this one more time. So we have this list of unique URLs. I think everyone can see here, basically stuff that we were showing earlier. The only thing I did was strip out all the static assets just because those are passed off to a CDN usually. But all these tools can be used to check that as well. All right, so now that we have this list of URLs, we can benchmark the traffic using this command. So what this is again the Siege utility. I'm just running it in verbose mode, that's -v, with a concurrency of 50 for 3 minutes. And I want to take the URLs from the urls.txt file, and I want to have a 10-second delay between requests. So we can copy these commands. And I'm going to decrease the concurrency so I don't destroy the server. And then you can start to see the request times. So I'm going to change the time just to limit it, so we'll just run it for 30 seconds. And you can see that the requests are flowing. So obviously the color scheme is fantastic with the black background and the really hard to read blue text. Just all sorts of win. And the idea here is that it's going to take all the URLs, read them sequentially, and then load test them with this concurrency. And then it'll give you a result at the end that gives you an overview for each one. Now, generally what I like to do is load test each endpoint individually at different levels of concurrency to figure out at what point does the throughput increase and the latency spike, because that's usually your happy medium. So here we can see the transaction rate across all the URLs is pretty horrible, 1.5 seconds, or 1.5 transactions per second with an average response time of 890 milliseconds. So not that great on this particular service. But it makes it really easy to discover complex applications and then work through interactions. But to your specific question, which is how do I go through complex interactions, I use something called Multi-Mechanize. But all of these tools, again, I'm an engineer, so I like to use the command line. Some people prefer a GUI, and you can write test plans really easily with a GUI through Apache JMeter. So Apache JMeter looks like this. Essentially, Apache JMeter is really good for load testing any sort of application, not just web applications. So you can load test JDBC, you can load test a database, you can load test really any protocol. But it makes it really easy to do in a graphical way. And then you can generate a graphical report, or you can generate just a simple graph like this. I just want to mention it because some people prefer this tool, but again, it's Apache JMeter. It's really easy to use. But to your question, I prefer Multi-Mechanize. So what Multi-Mechanize is, it's an open source framework for performance and load testing. It's written in Python, so hopefully everyone here has some basic idea of how to use Python. But the idea is simply to pip install Multi-Mechanize. And then you can bootstrap a new project with Multi-Mech, new project, and then demo. And what this will give you is it's really just a lightweight way to define transactions and run them at high levels of concurrency. So a very simple transaction might just be to go to acmedemoapp.com and read the response time. So it could be that simple. So this is the equivalent of running Siege with acmedemoapp.com. But this isn't really that useful. Oftentimes what you want is a complex interaction. So first I want to log in, then I want to add something to the cart, then I want to go through a checkout process, and I want to understand the performance of each one of those transactions individually, as well as the aggregate of all of them. And that's where I find Multi-Mechanize is really useful. So here I'm just importing the request library, which is a Python HTTP client, which is really simple to use. And then the Multi-Mechanize framework is really just the class transaction and the method run. So here you can do whatever you want inside of this method, and it's just going to run this in a loop at high levels of concurrency. So this could be as complex as you want. Now, oftentimes what you'll need is something a bit more advanced. So Multi-Mechanize also comes with a browser that can maintain state and pass in a cookie jar as well. So in this case, I'm using the simple request library, but in this, I'm going to use the Multi-Mechanize browser because I want to maintain the HTTP state along the way. So in this case, we'll just import Mechanize, import some timer, and then we can define this transaction. So I kept this transaction really simple just because it's going on a slide, but the idea here is that you instantiate a new Mechanize browser, and then I can create individual timers. So the custom timers are really easy. This just helps when you're creating graphs to process the data later. You can break down all the data that you want. So you can create as many custom timers as you want for each transaction, or for a roll-up of several transactions. It depends on what you want to measure. So in this case, I'm just creating Acme demo app. I'm making a request to Acme demo app, reading the response, and then creating a timer with a latency. So the start time minus the end time is our latency. And then I'm making an additional request. So I'm going to open up Acme demo app and go to the cart page, read the response, and then subtract the time, and that gives our latency. The additional benefit here is that you can do assertions. So I can check the response code is 200. I can check that the response body contains some text, etc. So you can use it for testing scenarios as well. What this will do is you can define, it's pretty configurable, you can define what levels of concurrency and how you want to run their groups. So you might have several scenarios, like I might have user sign up be one scenario. So I want to go to the home page, click register, fill out a form, and then process like an email validation URL. And that might be one scenario. The next scenario might be adding something to a cart and checking out. So you can define as many as you want, and they all roughly look like this. You just manually define the URL endpoints and go through the process. And then you can define different groups. So in this case, I'm only running one with one thread. And then I'm running, it's going to run for 10 seconds, and it's going to ramp up requests over 5 seconds. So it's not going to immediately start with 10 concurrent requests. It's going to ramp them up over 5 seconds. And the one thing that I really like about Multi-Mechanize is that it has great reporting. So it'll use Matplotlib to generate awesome graphs of each one of these data. So it'll give you the response time, and then it'll plot out all the data points for you. And these are all highly configurable. So definitely take a look at Multi-Mechanize. I find it solves this problem quite well. Now, by a show of hands, how many of you live in a cloud environment? How many of you are responsible for an application with more than one machine? Right. So oftentimes you need to generate more load than a single machine can produce. So what happens when, so all these load tests are running off of my current laptop, which is limited by basically the network throughput on this machine, which is this Wi-Fi. But what happens when you need more than one machine? What happens when you need to send 1 million concurrent users to your application? You want to send them through a load balancer and fan them out across all of your application servers? Well, you need to generate more load than a single machine can generate, and that's where I found a great tool. One, it has the best name I've ever found for an open source project, Bees with Machine Guns. It's amazing. It's also the only open source project I know that comes with a disclaimer that it's a felony to use this tool against any other site except for your own. So just a heads up, it's basically a distributed denial of service attack. So basically what Bees with Machine Guns is, it's a utility farming mini bees to attack targets, where mini bees is creating micro EC2 instances on AWS to load test web applications. So what this tool will do is allow you to spin up many EC2 instances and then use all of them to send load in parallel to your web application. So it makes it really easy to generate massive amounts of traffic in just a few seconds. So let's do that. So again, it's Python based, and it's written by the guys at the Chicago Tribune. So it's really easy to install. You can simply run pip install bees with machine guns, and then we can define some credentials. So in order to use this tool, you need to use Amazon Web Services. Amazon Web Services has a free tier, so you just need to sign up and insert your access key and access secret. But this is the only configuration that's required. Now what we're going to do is called Bees Up. What Bees Up actually does is it spins up some EC2 instances with a default image that has some tools built in, like Apache Bench is installed and Siege is installed to generate the load test. And basically all I'm doing here is saying I want to spin up 2 instances, and the default security group in the US West 2B data center, which is in Oregon, using this AMI ID and this SSH key and user. So it looks pretty convoluted, but it's relatively straightforward. I just want to spin up 2 instances, but it could be 2 instances or it could be 200 instances. It really depends on the level of load that you want to generate. So if you have a really large application, say you have a staging environment and you want to send 500,000 concurrent users through that, well, you're going to need to generate probably more than 2 instances. It depends on the application. So let's go and destroy somebody's website. It's separate, but there's a tool to make them run all in parallel. All right. Sadly, because my laptop crashed a bunch of times, all the prep I did for this sort of wiped out. So we're just going to go through it all. Any other questions? Not everybody at once now. All right. Go for it.
Sorry, I think I missed a question. Is this tool your application in the cloud?
No, it's just that it uses clouds. The reason I asked that is it's because who has a large deployment? That's really what it's about. Who has an application that's more than just 2 servers, 3 servers, where you need to generate more than a couple thousand concurrent transactions? Because figure at best, Tomcat's going to give you 8,000 transactions on not using any application framework on some decent sized hardware. Say you have 10 of those, well, how do I throw more traffic than that from a single machine? So what Bees with Machine Guns does is it spins up EC2 instances and allows you to throw the load at that. But your service could live anywhere. It doesn't have to be in a cloud environment. I asked that because the cloud's apparently all the rage. It's like big data and DevOps. It's really cool. Nothing. Cool. So Bees report will tell you how many bees are in the roster. So here I have 2 that I've spun up. So I just recently ran this command, which spins up 2 EC2 instances. And then I can run bees bees report, and it'll tell me how many EC2 instances are up and available to generate load. So let's make this a little bigger. Now, the best bit is these guys have a hilarious sense of humor, as you'll see from the output. So here we're going to call bees attack with a number. We just want to generate 1,000 requests at a concurrency of 50 for spring1-demo.cfapps.io. So it's going to read 2 bees from the roster. It's going to connect to the hive, assemble the bees. Each of the 2 bees will fire 500 rounds, 25 at a time, sting the URL so it will be cached, so it'll make a single request to cache it. And then it'll fire his machine gun, bang bang, until it's out of ammo. And the mission assessment, the target crushed the bee offensive. So the swarm is awaiting some new orders. So the basic idea is that we can easily handle this load. That's why the target crushed the bee offensive, but I can crank this up to like 1,000 and destroy this little EC2 instance. This pivotal web service instance. So what you see is that we can actually sustain 117 requests per second at this level of concurrency, and the average time per request is 424 milliseconds. Now let's destroy this machine. So this is a really small instance, so I'm just going to throw, let's say 500 concurrent users. That's going to pretty much destroy this thing. Again, firing his machine gun, bang bang, and then Swarm annihilated the target. So that means that server crashed and died pretty spectacularly. But it got up to 161 requests per second before the time skyrocketed to about 3 seconds per request. So the trick here when you're load testing your applications is really to figure out at what point do you max out the throughput, the number of transactions that you can sustain per second, before the average latency starts to spike, because there's always a trade-off. So one, you need to figure out what can your hardware handle outright, so you have a baseline for that, and then you need to figure out what your application can handle. And generally that's just running load tests at different levels of concurrency to figure out where that balance is. Because you can always get more throughput, but what's going to happen is your users are going to be waiting 3 seconds, and at some point your app server is just going to fall over because it can't handle the load. So the trick is to find the balance of the two. All right. So you can run this all day in different scenarios and figure out what throughput your machines can handle, but let's talk a little bit more. So again, bees report, it'll tell you how many bees are in the roster. You can run bees attack with a level the number of requests that you want to run, and the level of concurrency, and then the URL. And there's a bunch of other options, so check out the Bees with Machine Guns documentation, which is pretty spectacular. And then again, it'll show you the time per request, the average response time, and then whether you can actually sustain the load or not. Again, you can simply increase the level of concurrency, and you can do this to however many EC2 instances you want to spin up. So if you need to spin up 50, you can easily generate 1 million concurrent requests. So this is a really easy way to do. And again, because this is all running in EC2, the benefit of the cloud is that costs scale linearly with demand. So you can spin this up and run a gigantic load test for 15, 20 minutes or an hour, and then shut them all down. So in order to shut them down, we run bees down, and we'll turn them off. So I'm going to do that now. And it's just going to kill off the EC2 instances that we spun up for the load test. Now that covers really what I wanted to talk about on the server side. Are there any questions around load testing on the server side that I haven't covered for you guys at all? All right, so what about the client side? Because I find that oftentimes in modern web applications, there's more latency that comes from the client side than from the server side. So you spend more time in the browser waiting for assets to download, for the DOM to render, for the web page to become interactive, than you do for the 200 milliseconds on the server side for the app server to respond with the content. So it's just as important to understand the performance in the browser or on a mobile device as it is to figure out the throughput that a server can handle. And I think a lot of times backend engineers overlook that piece, but it becomes more and more important as more application logic lives on the JavaScript layer. So there's a bunch of great tools that are available to help solve this. So one is Google PageSpeed. Google PageSpeed comes in a few different forms. It's offered as basically Google PageSpeed Insights. It's offered as a website, which I'll show you right now, which basically gives performance advice. It's offered as a Chrome developer tool, and then it's offered as an API. So all the stuff that I'm showing you here, I like to automate through Jenkins so that it happens every time I do a new build. So you can understand the relative difference of every feature change. So let's actually take a look at PageSpeed, just because I think it's a great tool. So in case that's not readable, it's developers.google.com/speed/PageSpeed. So essentially all you do is type in a URL and it'll give you some performance advice. So here I'm going to use acmedemoapp.com. It'll download the page and analyze it and give you some basic performance tips. Now a lot of this is common sense, like you should use far future expires headers for static assets like CSS and JavaScript. You should minify CSS and JavaScript. You should defer some content to the bottom of the page. But what this will give you is actionable tips, which I find really useful. So in this case, it's not too horrible. But basically, I should enable compression. So I should serve all of my assets and my web pages using gzip compression, which is pretty standard. I should leverage browser caching for the site itself. So in this case, I should set like a cache control header or an expires header, depending on whether I want to use expires versus validation, and then reduce the server response time. So there's a bunch of different actionable tips. But the best thing about this is if you're using Apache or Nginx, there's a PageSpeed Insights module that will automatically fix all of this stuff at runtime. But a better approach is to fix it as part of your build and deploy process. Like I don't want to have to cache all of the CSS and JavaScript on my server at runtime. You should just compress and minify that at build time. So there's a lazy way to do it, and then there's the right way to do it. I'm an engineer, so I generally prefer lazy, but I try to do right when I can. So I think that PageSpeed is a great tool for that, just because it allows you to really easily understand how you can improve the client side. But oftentimes that's not enough just to have the high level tips. You need to understand where you're spending the time on the client side. So there's a great tool called WBench that will run your web page inside of a headless browser. So it'll run it inside of Chrome and then give you the performance timings on the client side as well. So you can, this is a Ruby tool, so you can install it with gem install WBench. I apologize, it's not all Java guys. Apparently all these tools aren't available in Java. But basically what you can do is run WBench against a URL. It'll open up a Chrome instance and then give you all the client-side performance timing. So it'll use the W3C navigation APIs and resource timing APIs to tell you where that time is being spent. So oftentimes it's not necessarily things that are in your control. Like you might rely on a third-party site for some assets, and that site might be very slow for whatever reason. So it's being able to give you visibility into that. So my personal website, dustinwhittle.com, just relies on dustinwhittle.com and google.com for some assets for basically web fonts. So what's the DNS resolution time, and then what's the latency to just connect to that server? And that will obviously vary depending on where you're running this test from around the world. But it'll also give you a breakdown of the browser performance. So this changes, this is all relative to the browser that you're running in. In this case, it was just running in Chrome. And it'll run 10 loops, so 10 iterations, and then give you the average overall. So in this case, it's taking on average 30 milliseconds to connect to my machine. About 19 milliseconds of that is just DNS lookup time. And then you can see that the DOM is loaded in 107 milliseconds, but it takes about 1 second for the page to actually become interactive. So what you can see here is that even though my website responds to this request in only 30 milliseconds, a user can't use that page for 1 second. So what's the time difference there? Again, it's not about how fast your application server responds, it's about the end user's perceived latency, right? Because it doesn't matter if you say your servers are really fast, if a user uses your website and they perceive it to be slow, they're gonna have a bad experience. So it's about being able to understand that as well. So here we basically get a breakdown of the DOM interactive, DOM complete, and then you can actually add custom events if you want. But it's very easy to automate client-side performance testing with a tool called Grunt. So Grunt, if you're not familiar with it, it's basically a command line for automation that's written in Node.js. But generally, I manage assets with Bower for dependencies. It's a way to manage front-end assets like CSS and JavaScript. Grunt for automation, so that I can minify and aggregate my CSS and JavaScript at build and deploy time. It's basically comparable to Maven or Gradle, except for without the package management stuff. And then Yeoman for bootstrapping. If you just want a good template for a web app, Yeoman provides a really good foundation. So if you're just trying to get started and you want best practices for all the stuff built in, you should use these tools out of the box, because this will give you most of what I'm talking about here today. And it's really about automating it, because you can do all this stuff manually, but it's really about being able to do this once, put it in Jenkins, and then have these generated as reports every build. So again, Grunt makes it really easy. It's a JavaScript task runner built in Node. And one of the nice things about Grunt is it has built-in support for PageSpeed. So it'll give you the PageSpeed advice every build. All right. How many of you would say you work for a reputable web company, like you call yourselves a professional? By a show of hands, maybe is better. All right, so about half of the people in the room are professionals. How many of you understand exactly how fast your site runs in production? By a show of hands again, let's go with show of hands. Yeah, some people use monitoring, the rest of you not so much. You wait till a user complains and that's when you know. Yeah. Okay, so you should really track performance and development in production. And the reason I'm harping on about this is that the whole point of running a load test is to figure out where you have performance bottlenecks, but it's only good to run a load test if you have instrumentation along the way. So a large part of what I'm talking about is you need to instrument all of your code. You need to really instrument so that when you generate massive amounts of traffic, that becomes meaningful data for you. So you understand, is it slow in the application server, in a cache layer, in a database? Am I filling up the queue too quickly? Do I need to add more workers? Where is your system broken, basically? So I think you need to track performance in both development and production. And you should instrument everything. Instrument your code, instrument databases, caches, queues, third-party services, and infrastructure. Oftentimes what you'll find with performance bottlenecks is it's not necessarily your service. It's a third-party API that you rely on that you might get rate limited on once you hit some level of concurrency, or you might have a cache layer that fails over after some bit. So you really just need to be able to instrument that so that you can have some insight there. So I use a variety of tools to get visibility into this. So one, I'm a big fan of Chef and Sensu. The Chef part's not really important, the Sensu bit is. So what Sensu is, it's an open source monitoring framework that allows you to read metrics from pretty much any application service. So I can read metrics from Nginx, from Tomcat, from Jetty, from whatever service, and I can put those metrics into a sexy dashboard. So when I'm generating load tests, I can see what's my memcache hit miss ratio, what's my level of concurrency to talking to some Oracle database, and basically it makes it really easy to monitor those, and more importantly, put those stats into something like Graphite. So that's the next bit. So Etsy has released something called StatsD. It's a really easy way to just capture statistics, and custom metrics. It's whatever you want, really. Below that, there's something called Graphite, which is a data store for metrics and a way to graph time series data. And then there's Grafana, which is a sexy dashboard for time series data. So the net result of all of that generally looks something like this, which is a really fancy dashboard that will tell you how much traffic you're generating and then where that traffic, the statistics around your application. So that could be everything from cache hit miss ratios to average response time, to how much time are you spending on the client side, to number of 404s, 500 exceptions. It's really whatever you decide to instrument. But the reason I talk about this so much in a performance talk is because the whole point of load testing is to get insights from what's wrong with your application, and you can't do that unless it's well instrumented. So it's not just enough to load test your server and see where it fails and say, okay, we need to just add more hardware at the app server level. Maybe that's not always the case, and the only way you're going to figure that out is if you instrument. The other piece is tracking the performance of end users. The reality is that there's a bunch of different libraries that I'll talk through in just a second that allows you to understand your end user's perspective. Because it's not what you think your application server is doing, it's about how's the application performing for your users. That experience is very different on a web device connected over very fast Wi-Fi, and it's very different on a mobile device connected to 3G. It's also going to be different in Chrome on Mac versus Safari on Windows. So you need to be able to test the browser and the client-side interactions as well and capture those times. Because the web is really diverse, right? You have every version of Internet Explorer, every version of Chrome, every version of Safari, and then you have every distribution of operating system. So being able to see, and from your real user's eyes, their experience allows you to sample that distribution and to sample the experience across all the different browsers and all the different platforms. So there's a couple libraries that make this possible. So the guys who wrote Google PageSpeed, or rather Steve Souders, who originally wrote Yahoo's Why Slow and then went to Google and ran Google's performance engineering team, and he wrote something called Episodes. And then his counterpart at Yahoo wrote something called Boomerang. Basically what those things do is they're small bits of JavaScript that you can insert into your production application that will capture the client-side metrics, like how much time are you spending on DNS resolution, SSL connection, how much time are you spending on downloading CSS and JavaScript, how much time are your users waiting before the page becomes interactive. And it's capturing it into your real user's eyes. So you can really get an understanding of if your users are having good experiences or not. So it's not just enough to run these load tests on occasion just to make sure that you're capacity planning appropriately and not failing over, but also to make sure that users have good experiences. So what this is a bit hard to read, but basically the idea here is that you can capture, let's try a different technique. There we go. So the idea here is that this is episodes, and episodes simply is a small bit of JavaScript that you insert into your page and that every user will run. And what this will do is it'll track page load time, how much time you're spending on the server, so the server connect time, and then how much time you're spending on the front end. So the first byte time, and then you can track custom JavaScript events if you wanted. So at what point did all the AJAX interactions load? At what point was jQuery ready and my application was ready to be used? And the best bit is that you can beacon all this data back into StatsD, into Graphite, and then you can put it in a dashboard and you can get an understanding of your real user's performance. So yes, so it's not always easy to insert JavaScript into your application and just let everybody report this data back to you. So when you can't do that, you can simulate that through a variety of locations. The other bit that I forgot to mention is that because the web is so diverse, it's not just people running your application from your location. And what I mean by that is just because I'm running my data centers in Oregon, everybody on the West Coast might have a good experience, but if you're in Australia, you're still going to have added network latency, and that network latency is exacerbated by every network request. So you really need to understand the experience of your end users from different locations as well, because not everyone has several $1 million to put servers all around the world to make it really fast for people. So a way to test for that is a great tool called webpagetest.org. It's a really simple way to simulate traffic for web applications from different locations around the world using different browsers so that you can understand exactly what the timeline is in the interaction. So what it looks like is you go to webpagetest.org. You can simply put in a URL. So let's go and do this. So I was in Wellington, New Zealand a couple days ago. So we'll just run that from here and Chrome. And you can run different settings. So I like to run a couple of tests so I can see the average over time. And then the best bit is that you can record a video. So if you can use this for all sorts of things. It's not just for performance testing. You can use this for quality assurance as well. So you can capture a screenshot. You can capture a video of the entire page rendering. So you can see when you're having real problems. So let's do that. So basically it's going to load. Apparently they have a great book out called Using Web Page Test. They highly recommend it. Nothing. All right. And the idea here is that you get a waterfall breakdown, a screenshot, and a video of the rendering of the page, so you can understand how much time is being spent on the client side, as well as the network latency from that particular region. So in New Zealand, the internet's going to be really far away from this particular data center, which is based in Oregon. So what you'll see is more network latency. So we can drill down. So you have a screenshot of both applications. You have the first view, and then you have the cache view. So another piece is when you're having cached assets on the client side, what is the time for a page when everything's totally uncached? And then what's the experience when all the assets are cached? So that's the benefit of this. And again, if you've ever worked in Chrome or done any front-end development, you're probably used to this waterfall time. But you can see that there's load time was about 3 seconds. First byte time was about 1.5 seconds. And then we rendered about 3.2. And then we're actually able to interact with the page at about 3.5 seconds. But more importantly, you can see where was that time being spent and what were the domains. So I have a bunch of assets here, and what you can see is what assets get downloaded in parallel and which assets get downloaded serially, and all the different domains that you rely on. So you can get an understanding of how much time you're spending and then how much time is being spent on the client side. The other useful bit is CPU utilization. So how intensive is it to render your page? So for most backend developers, probably don't care about this, but it's good to understand because I think the web is moving in a direction where you're pushing a lot more of the processing into the browser. So what I've seen is a lot of applications that were once very monolithic, just WebSphere talking to an Oracle database, are now moving to be just like a JSON API where all the logic lives in the browser in Ember or in Backbone.js, and they're just using the data from the JSON API and they're gluing it all together in the browser. When that's the case, the browser is not a shared resource. So if I'm on a really low-end computer, I'm going to have a much worse experience than if I'm on a brand new MacBook Pro. So you need to understand as you push the logic to the client side, that's something that you can't control anymore because it comes down to the client-side device. And even on my MacBook Pro, maybe if I have 50 programs open, it's not going to render as fast. So you need to be aware of that. All right. So again, waterfall breakdown. The next one I really like is sitespeed.io. So I recommend everyone check this out. So sitespeed.io, basically what this does, it's a little bit of a pain to install, which hopefully these guys will eventually fix. But it's available, you can run it on Linux, Windows, and Mac, so it's pretty portable. And what it gives you is essentially a better version of PageSpeed with a bunch of more assets included. So this is a bit harder to read, but what you can see is a PageSpeed score. Let's just zoom into each one of these. So you can see the PageSpeed score. So what's the rule? The reason this is valuable is as you iterate on your code, you add features on the server side that probably either increase or decrease your server-side latency, and then you add some interactions on the client side. So every release, the performance changes. So you need to have an understanding of when you add new features, what's the relative impact of each one of those features. And sometimes that just means the server side got a little faster, but the client side got a little slower, but you need to have insight into that. Sitespeed makes it really easy to understand this. And it also gives you some basic optimizations. So the number of requests without gzip compression, the average weight of CSS and JavaScript, number of domains. If I added a Twitter social sharing widget when I need to resolve the Twitter API, Twitter URL, sorry, the Twitter domain, and download the Twitter JavaScript, what was the impact of that? And then the total page weight. But there's a bunch of different useful metrics that I find that SiteSpeed provides. So sitespeed.io, it's really easy to install, and you really just run sitespeed. Go ahead. What's that? I believe it's the previous run. So you can run multiple times. So it's against the previous run. So I don't want to plug my company, but I'm here to plug my company. So I work for a company called AppDynamics. Basically, the reason I mention this is when I talk about instrumenting your code, what we provide is the ability to really instrument and monitor applications in production and development. So our competitors are companies like New Relic, companies like CompuWare. Doesn't matter to me whether you use our tool, it's that you should be using something to monitor your production. So there's easy ways to do this with open source tools like Sensu and Twitter's Zipkin, and there's a bunch of tools like this that make that available. But my point here is simply that you need to monitor your performance, and that's really easy to do. You can either build it yourself with open source and a bunch of different solutions, or you can use a commercial tool like AppDynamics. Basically what they do is everything that I've talked about. When you're having performance problems, where are the performance problems on the server side? When you're having client-side interactions, you can see basically where's your traffic coming from globally and how much of that time is being spent in different browsers, and you get a breakdown of distribution. Check it out, almost all of them you can use for free, but the idea here is that you just should be using something to monitor your services. All the tools that I've talked about are generally available as open source components that you can plug into any project. But oftentimes, you just need to get the job done. So there's a bunch of services that you can use in cloud environments, which I'm a big fan of. So there's Apache. So, and to my point is, again, I'm an engineer, so if I can just download an open source library and write 2 lines of code to generate this, that's my preference. But oftentimes, you're just solving a business need. And the business need is, hey, are we going to fail on launch day? And you need to be able to answer that question. So you can either build it yourself, or you can pay a third-party service. So I like to mention both. So Apache is a load testing tool that allows you to generate load from around the world. It's much like what we've just done here, but with a bunch of data centers around the world. It makes it really easy, and they have a great web UI to use it. A competitor of theirs, and also a good tool, is blitz.io. So if you just need something quick and dirty, I'm a big fan of blitz.io. So basically, it's just like bees with machine guns. I can go in, I can type a URL, and I can say, okay, generate 500,000 users and send it to this URL. And then get a report basically saying the average response time, the level of concurrency, etc. And then there's BlazeMeter. So when I talked about JMeter earlier, basically this is a cloud-based version of JMeter. So you can run it from all sorts of different locations. Some of these tools are better for web applications versus mobile applications, but if you need something quick and dirty, all of these tools will get the job done. So I'd recommend taking a look at any one of them. All right, so I think oftentimes people forget to test for failures. It is an imperfect world. I know it's really unfortunate to accept that, but at some point in life you do. And what you realize is that things break. Another way to say that is that shit happens, right? And you really need to load test against failures. You need to understand what happens if I lose that caching layer, what happens if we lose half of our database slaves, or we lose this data center. And oftentimes those problems, you don't find those problems until you're at high levels of concurrency. So, okay, you never saw that in your dev environment, but you should have tested it in your staging environment, because that's when you see those problems. It's when you crank up the traffic that the concurrency issues manifest themselves, right? So you really should test for failures. And the same load test that I would run, the under success conditions, I would run if I turned off memcache layer, dropped the Redis database, or cut our database throughput in half, right? So Netflix has released a bunch of tools that make this easy. So through Netflix Simian Army, they released something called the Chaos Monkey. So if you live in Amazon Web Services, what Chaos Monkey will do, will go in and randomly kill off services, add network latency, basically just cause chaos. And it'll allow you to simulate real failures in production environment and to see how your application responds. I think this is critical that most people overlook. Like healthcare.gov didn't fail because nobody ever looked at it. It's because when they looked at it, it was that one guy on the final version of it running just one person. Not when 100,000 people show up on that day, right? So they didn't find a lot of those problems, and that stuff didn't manifest itself until it was too late. And there's a lot of easy ways to test for it. So what I recommend is turning on something like Netflix Chaos Monkey and then also running your load tests. But there's very easy ways to simulate this yourself. What happens if you cut your concurrency down? What happens if a third-party service goes down? I've been a part of some spectacular failures in my career. And one of my favorites was not setting a cache timeout on a third-party service API call. So if a third-party API goes down, but accepts the connection and the connection just hangs for a second, how long do you wait for that? You should set short timeouts, right? You should set short timeouts and you should retry and exponentially back off. But if you don't think about that ahead of time, what happens is all these requests come in and you just wait for this connection that's going to wait for 5 minutes, 6 minutes, whatever it is, 1 minute, and then all of your users are blocked, right? So these are the sort of things that you should test for, and these are most of the time, they don't manifest themselves until it's too late. So the more upfront planning you do, the better off you will be. Okay, so some best practices. Capacity plan and load test the server side. So John Allspaw, who did all the web operations at Flickr and then moved on to Etsy, wrote a great book called The Art of Capacity Planning. If you are responsible for large web applications and you have a big launch day, I'd highly recommend reading his book. But really, it comes down to you need to forecast what your load should be and prepare for that. And that comes down to capacity planning and load testing the server side. Next is optimize and performance test the client side. Again, more of the logic lives in the browser nowadays, and the browsers are very diverse on the internet, so you need to understand the performance across all of them. But you need to understand your starting point, so you need to really instrument everything. You can't understand the delta or the change for every new feature, whether you upgraded MySQL or Oracle, or you switch from Braintree to PayPal or from some third-party service, unless you've instrumented it. So you really need to understand your starting point so you can measure the difference of every change. And then you should automate performance testing and your build and deployment process. There's no reason that this should be a one-off process. I've done a lot of performance consulting, and what I find is that I go into a team, I work with them for a couple of weeks, I add all this stuff into their process, and then I leave and they call me back a year later and they say, hey, we'd like to do that again. And I was like, well, the whole point of this is that you should automate it. That's what we set up, so you should automate all this stuff just so that every time you do a new Jenkins build, you get a new performance testing report. You get a new site speed report, and you can understand the change for the features that you just added. And then understand how failures impact performance. I can't stress this one enough. The reality is, failures, they show up on launch day. They don't show up ever before that. It always catches people off guard, by surprise, and it's things that you can easily test for. So again, integrate automated performance testing into continuous integration for the server side and for the client side. Oftentimes they just look at the server side aspect, which matters for backend developers when all you need to measure is your throughput, but often you're overlooking the client side. And then understand the performance implications of every deployment and package upgrade. So sometimes people look at this as just their code, but I actually look at it as a lot more than that. If you're switching from one cloud provider to another, if you're switching from one database platform to another, if you're just upgrading minor versions from Redis 2.4 to Redis 2.6, like what was the performance impact of that? So you should really understand. And then monitor the end user experience from end to end in production. So not just your server side, but also your end users, because that's where the most valuable information comes from. Maybe all of your Internet Explorer users in Australia can't use your website. Well, you never know until somebody complains. So you should instrument their browsers as well. And that is all I have for you. Any questions?
Tips or tools that you use for actually monitoring resources like operating system resources, database resources, anything like that?
Yeah, so the question is, are there any tools or tips for monitoring system resources? That's where Sensu comes in. So I'm a big fan of Sensu for monitoring everything. I use it to monitor everything from Nginx concurrent connections to memcache hit miss ratios to Tomcat response times. It's very flexible Basically, they have metrics collectors for everything you can think of, for not only for all the operating system stuff, but also for all the application services. Again, there's a bunch of old school approaches like Nagios's and Zabbix of the world that also work. I just think Sensu is a better way to do this nowadays. And the best part is you integrate that with like a DevOps tool, like a config management tool like Chef or Puppet. And what you can do is you can just define, okay, this is an app server. An app server consists of these services. So I automatically want to pull stats from each one of those services. And it's all done sort of magically. So that's what I'd recommend. Any other questions?
Yeah, are you using Sensu for like longer term metrics, like potentially months and years over releases, or just within those?
So all of the Sensu metrics go into Graphite, and then it just depends on how much you want to store over time. But yeah, generally I keep them forever. It's basically just limited by disk space storage, and then you can put them in Grafana and you can graph out over a year. And that's really actually good for seasonality. So maybe Black Friday last year, where did we have problems in our infrastructure? Let's make sure we don't reproduce that. It's also good to spot trends. So every 2 a.m. on Sunday when we run that database maintenance, the database maintenance or whatever it is, we see these other changes. So it's that sort of stuff that you can detect by having that data for a long time. Any other questions?
How do you feel about trying to extrapolate your production server needs by using servers like using just one server in a performance test environment?
Yeah.
Is that a good idea, or is that bad?
So the question is, how do I feel about using a single server instead of reproducing a QA cluster and extrapolating the relative performance of that single server versus what I would have in production? So this is where I would say, so one, I'm against it, just to be totally clear. The reason for that is cloud environments and DevOps tools have made it so easy to spin up an entire new cluster for my production applications, I can spin up an entire new version in under 10 minutes using Chef and Amazon's EC2 or Pivotal Web Services. So with tools like that, if you can spin up a new QA environment, I would rather spin up an entire production environment for a day and run load tests against that, because the reality is you're never going to see those problems. Again, a lot of the problems you see when you have high levels of concurrency, until then, everything looks good. So if on a single server, you might be able to detect some stuff, like, hey, we saturate database connections whenever we go over 1,000 concurrent users, or whatever it is. But you're not going to see end-to-end what's going on in the system. And I think that's the most valuable data. Any other questions?
So, organization, where do you see this fitting in? So should each team be responsible for this, or should we have one centralized application?
So I catch a little bit of flack for this. I think engineers should own it. Like, you should be responsible for your code. And that doesn't just mean that once I've committed that feature, I'm done. And I think a lot of engineers have that mentality. And the more that you work, this comes from previous to my current role. I was CTO of a startup in San Francisco. And when you're on a team of 5, and you're not only responsible for the engineering, but also the operations, you just change your mentality of how to deal with it. So like, you own the problem all the way to the end. So now when I work in a much larger enterprise, I sort of have that mentality. So I think engineers should own it. Now, oftentimes in a large organization, you don't have generalists, you have a bunch of specialists. So you can afford to have an operations team that specializes in performance testing. And if that's the case, then I would say they own it, but that doesn't mean that engineers are off the hook. That's probably the best way I can answer that. A little louder, I can't hear, I'm sorry. Yeah, so there's a couple of different ways. Generally what I do is I just hijack the DNS and I stub it out. So that's one approach. Oftentimes you can just configure it, so it's relatively easy to do. When I can, I mock them. But there's other ways to do that. So like, one of the things that Chaos Monkey can do is just add network latency. So oftentimes the service isn't just going to be down completely, it's just going to take 5 seconds to respond. So what you want to test for is what happens when there's a bunch of additional network latency for a particular provider. A good example of this is PayPal's API, like a year ago, had a bunch of incidents over the course of a year. And oftentimes it's not that the API would go down, it was just, it would take 10 seconds for you to get an authorization. Well, that's way too long, and most applications would give up after 2 or 3 seconds. So you need to, it just depends on what the dependency is, but oftentimes I would just try to simulate the failures or simulate additional latency and not just turn the service off completely. Because usually if you can't connect to a service, you kill that off really quickly because you have some sort of connect timeout. But it's once I connect, what's the timeout for the entire request? And oftentimes, I mean, I've made that mistake personally where I've just overlooked that. Connect timeout was very short, but the end-to-end timeout wasn't. Any other questions?
Yeah, what about when people are using your server-side components as looking at the cloud resources?
Yep. So JMeter is really good for that, actually. So I'm against JMeter because it's really like a GUI tool. One thing it's really good at is if I just want to call this method 10,000 times or open up 1,000 JDBC requests, like what happens? So I would recommend that. Oftentimes what I try to use is statsd and just track metrics and instrument my code so I can find that stuff out ahead of time without having to run something like JMeter to just call this method 1,000 times. But it depends on how much effort you want to put into it. JMeter is really quick and dirty, makes it easy to do. I think a better approach is to just instrument your application with statsd or whatever instrumentation platform you want to use, and then push it to production and see what happens. Or QA, whatever environment. Yeah, so there's a bunch of traffic replay tools that will basically take a look at your access logs and come up with, they'll do funnel analysis on like top flows. So this is a very common pattern, which is like, tell me the most popular flows that my users go through. So most people go, they sign up, they add to cart, then they check out. But that's what you assume. Maybe most people go to the popular page, they look around, they click on the page a couple times, and then they add to cart, right? I can't remember the tool off the top of my head, but basically, so varnished replay is one that will allow you to take a varnish cache server and replay the access logs. And then there's a bunch of tools that allow you to do funnel analysis on the access logs, although yeah, stop by after and I'll follow up on email. I can't remember the name of the tool, but there's a really good one that I use. I'll follow up via email. But yeah, generally they all work by just taking a look at your access log, mining that data, doing top 3 like funnel analysis, and then you can use that. That's usually the best thing to do because that gives you real world traffic. The other things, I mean, you can use analytics platforms to determine most of this. So you can go into Google Analytics and pull this relatively quickly. Any other questions?
Any quick horror stories or experiences where the art of measuring or instrumenting something has caused you to kill the performance of an app?
No, but I've paid a lot more money than I had to by over-provisioning because I thought that, so again, the benefit of the cloud is the cost scale linearly with demand, but it's really easy to over-provision because you're just like, well, I'll just add 10 more just to be safe. And that costs like 200 grand 1 month, so that wasn't good. Yeah, so basically no horror stories from those sort of failures. Mainly the failures that I've had are like error conditions that I didn't account for that later blew up right in my face. Yeah, probably don't want to account those on camera. Yeah. Any other questions?
When you were showing WBench, you mentioned that you could tell when things first started loading and then also when it actually became usable. How did you determine when the user actually started?
The DOM interactive event. So the W3C, the standards organization, has released something called the navigation timing APIs, which give you an understanding of what happens inside the browser when you're loading a page. So WBench actually adds a level on top of that because they're actually looking in the browser. They can measure like the SSL connection time and the DNS resolution time, which is really useful to know. But basically they use the W3C navigation APIs to figure out when the content's loaded versus when the DOM becomes interactive. Yeah, and it's the DOM interactive time that's the most interesting because that's when you can start to use the page. Any other questions at all? All right, well, thank you very much for joining the talk. If I can ever be of any help, please feel free to reach out on email or on Twitter. You can find these slides on speakerdeck.com/Dustin Whittle. And thanks for joining. Now remember to test and monitor your applications.